one of the roots of the equation x cubed plus 2x squared plus ax plus b equal to 0, where a and b are real, and one of the roots is 1 plus half I as given in the question, and the question says find the other roots of the equations and the values of a as well as the values of b. Okay, so here there is a couple of constants here. We need to find the values of a and b. So first, okay, the function, let's call this a function of x. Okay, the function of x is x cubed plus 2x squared plus ax plus b, and since this is one of the roots of the equation, right, so this value, okay, if I substitute in the value of x, it should be able to satisfy this given equation. So let's substitute x with 1 plus half I. So f of 1 plus half I is equals to x cubed. So I'm just going to put in all the x's in this expression given function of x, all the x's with 1 plus half I. Since that's a root, it should be able to satisfy the equation. So 1 plus half I cubed plus 2 times 1 plus half I squared plus a times 1 plus half I plus b. So now the 1 plus half I cubed, I'm going to split it up as power 1 and a power 2. Okay, so 1 plus half I times 1 plus half I squared. The reason being because here I've got a power 2, right? So when I expand this, so I could just simply replace this with whatever expansion I get here, then I can expand it with 1 plus half I. So that's the only reason. So other than that, there is no special reason for doing that. So this one is, we can use a plus b squared format. So a is a 1, so 1 squared is 1 plus 2 times 1 times half I, which is going to become the half and the 1 will cancel, which is going to just give us just the I. And then we have got a half I, then squared. The half, if I square it, it's going to become 1 quarter, and the I, if I square it, is just going to become I squared. So I just left it as I squared at this step. So in the next step, we know that I squared is going to become a minus 1 times positive 1 quarter is going to become negative 1 quarter, which I could combine it with a 1 to turn it into 1 minus 1 quarter, that will become 3 quarter. But anyway, the next one is a very simple step. So a times a 1 is of course a times half I is going to become a over 2I, and the plus b I just copy down as it is given. So now, okay, this part is going to be 1, okay, this part will be minus 1 quarter, 1 minus 1 quarter is going to become 3 quarter. So I will just simply replace this with, okay, 3 quarter plus a I. Okay, so 1 plus half I didn't touch. So this part is 1 plus plus I minus 1 quarter, because I squared is going to become negative 1. Negative 1 times positive 1 quarter is negative 1 quarter. So plus 2 times, okay, the same thing, 1 plus I minus 1 quarter. And this part, okay, we don't have to do anything, just copy down for the time being. Now this is 1 plus half I, and this part, if you simplify it, it's going to become 3 quarter plus I. Right, so here the 2, and okay, this one I have expanded it 2 times 1, 2, of course 2 times I is 2I, and 2 times negative 1 quarter is negative half. Of course, if you wish, you could simplify this as a 3 quarter and then times by 2, so you would save some steps here. So a plus a over 2I plus b. Now let us expand this. Okay, 1 times a 3 quarter is going to become 3 quarter, and half I times I is going to become half I squared, which would become negative half. So we're going to have 3 quarter minus, okay, half. So from 3 quarter, if you minus a half, it's going to give you 1 quarter. And then for the complex number, 1 times I is just simply a I, and 3 quarter times half I is going to become 3 over 8I. So to 3 over 8I, if you were to add 1I, okay, 1I you can consider it as a 8I over 8, so which is of course going to combine to turn into 8 plus 3, that's 11 over 8I. Okay, so you can do it slowly if you wish. Then this part, okay, 2 minus 1 quarter, which is of course going to become 1.5, that is 3 over 2, plus the 2I just copy down, and the rest of it I'm just going to copy down as it is, right? A over 2I, which is here, and the a and the b I put it together. Okay, a plus b. Now let's regroup all the real parts together and all the complex parts together. So you've got a 1 quarter, which is a real, 3 over 2 is a real, and a plus b is also real. So we can just put these four terms together because it doesn't have any I. And then let's put all the complex together, okay? 11 over 8i and 2i and a over 2i together. And of course, we're going to factorize out the I and write the I outside. So we have a 1/4 plus 3 over 2 plus a plus b. Okay, that's a real part. Okay, and 11 over 8 plus 2 plus a over 2i, that is the imaginary part. And in the next step, we can combine these two together. I mean, this 11 over 8 and 2 together. Okay, and I think it is going to become something like 27 over 8. So here 1/4 and 3 over 2 also we can combine it. So let's do that. So if I were to combine 1/4 and a 1.5 together, it's going to become 7/4 or 7 over 4 plus the a plus b. I'm just going to copy down as it is. So 11 over 8 plus a 2 is 16. 16 plus 11 is going to give you 27. So it will be 27 over 8. And a over 2, if I change it to the denominator as a 8, so I'm going to multiply the a with a 4 and a 2 with a 4. So it's going to become 4a over 8. So I could merge the fractions together and write it like that. So this is the simplest, okay, result that we can get. But since we substituted this, okay, this must have been equal to 0, right? I mean, when you substitute the root, the function should be equal to 0. So since x is equals to 1 plus half I is the root of the function x, so the function of f of 1 plus half I should be equal to 0, which means this whole thing must be equal to 0. So if it is equal to 0, of course the coefficient of I, which is the imaginary part, should also be equal to 0, and the real part should also be equal to 0. 7/4 plus a plus b should also be equal to 0. And of course in this expression, okay, from the coefficient of the I, we could see that a is the only unknown, so we could just solve for the value of a. So if I cross multiply the 8, 0 times 8 is going to become 0, right? And then the plus 27, if you throw become minus 27, and therefore the value of a should become, okay, a equal to minus 27 divided by 4. So minus 27 over 4 should be the value of a. Since we got the value of a, we can substitute into the second equation here, and we can look for the value of b. So you've got the 7/4 plus, okay, the value of a is minus 27 over 4. So let's put that in there, and plus the b equal to 0. So this is 7/4 minus 27 over 4 is going to become plus minus is going to become minus. So this will become minus 27 over 4. From 7 you minus a 27, it's going to give you negative 20 over 4. And how much is negative 20 over 4? Which is of course equal to negative 5. And if you take the negative 5 and you throw over to the right side, it's going to become positive 5, thereby giving you the value of b as just 5. So there we have the values of a and b. Since we already found the values of a and b, now we can write down the function of x with the known values of a and b. So therefore your function of x is equal to x cubed plus 2x square plus the value of a, which is minus 27 over 4. So we can write it here. Then we have got the plus 5, which is the value of b. So there we have. So write it down. So that is your function of x. So we have already found the values of a and b ready. So now the question is also asking you find the other roots of the equation. This is a cubic expression. There should be altogether 3 roots. So we are already given one of the root, and of course if one of the root is a complex number, the other root must be the conjugate of this complex number, 1 plus half I. So since x equals to 1 plus half I is the root of the function x, the other root must be 1 minus half I. Okay, that should be the other root. So this is the second root, and if they are the roots, so we can write it as x minus the first root, which is 1 plus half I, which was what was given in the question, and the second root we already know it's a conjugate, which is 1 minus half I, which is the second root. And then we do not know what is the third root. So what form is the third root is going to be? It should be of the form x minus k or x minus a or alpha or whatever you feel like writing. So I'm using x minus k. Now why x? Why not ax? Okay, because the coefficient of x cube here is a 1. So x times x times x is what that's going to give you the x cube. So I just simply kept it as a x minus k. So the k is basically the constant. Right, so now let us simplify. So this part we can open up the bracket here. It's going to give you x minus 1, and then minus plus is going to give you x minus 1. This should be minus half I, and this should be x minus 1 minus minus is plus half I, or there's a mistake here. This should have been a minus half I. So x minus k. So hopefully in the next step I have rectified the mistake. Oh yes, I did. This is of the form a minus b, a plus b. So it should be a squared minus b squared. So x minus 1 squared, your b is half I, right? So it's half I squared, okay, times x minus k. Okay, so take note that there is a mistake here. This should be a minus half I. Okay, so let us expand this. X minus 1 squared, if I were to expand using the formula a squared minus 2ab plus b squared, and this part half, if I square it, it's going to become 1 quarter, and I, if I square it, it's going to become negative 1. Negative 1 times a negative is what that turns it into a positive 1 quarter. And the other factor is, I'm still keeping it as x minus k. So this part, if I expand it, it is x squared minus 2ab minus 2x plus 1, and this part is a plus 1 quarter times x minus k. So there we have it. The 1 and the 1 quarter, we can combine it into 1 and 1 quarter, or we can write it as 5 quarter, right? So let us expand this now. This is 1 plus the 1 quarter, I put it together as 5 quarter. And now, of course, we know that the constant times a constant is the only way for you to get a constant, okay, whose value is 5. So plus 5 quarter times minus k is going to give you minus 5 quarter k when we compare the constants. And the minus 5 quarter k should be, of course, equals to the 5, okay, which is on the left side. So if I cancel the 5 and the 5, and what would be the value of k? Of course, you're right. So it should be equals to negative 4. So if you throw across the negative 4, so k value should be equal to negative 4, and therefore your function of x is going to become x minus the first root, which was given to you in the problem, 1 plus half I, and then the second root, which is basically the conjugate, which is x minus 1 minus half I is the second root, and the third root is with the value of k replaced with a minus 4. So x minus minus 4 is going to become x plus 4, right? So that would be the third factor. So for you to factorize the other two roots, okay, since it's a cubic expression, this was one of the roots already given to you. So the question says find the other roots. There are a couple of roots. So one of them is the conjugate of what was the given root. So 1 plus half I was the given root, 1 minus half I is the second root. And if x plus 4 equal to 0, x value should be equals to negative 4. So x equals to negative 4 is the second root. Okay, so there we have it. We have found the other roots of the equations as well as the values of a and b as needed by the question.